I'm Viraj. I'm here to answer an age-old question. Who cares about calculus?
Now, the word calculus actually comes from a small stone which you use in an abacus, but I prefer to think of it like sand.
If we have a function, what happens when we add a grain of sand of x? If we have a circle, what happens to its area when we add a grain of sand of radius? And speaking of areas, when we have a graph, what's the area? Or better yet, what's the number of grains of sand which we can fit under a curve?
Here's a question. If I'm running and my speed is changing, what's my speed at a specific time? Before we answer that, let's answer another question. What's my average speed?
Well, we know how to do this. To get the average speed, we just do distance traveled divided by time taken, and that gives us the gradient that we see in red. However, that's not exactly the gradient of the tangent line at time t. This is an approximation. To make the approximation better, we can reduce the interval over which we're taking time.
You know what would make this approximation perfect? If we could make the time interval 0. That way it wouldn't really be an approximation. There's only one problem with this. Velocity is displacement over time. So displacement over 0.
Fortunately, there's a solution in something called limits. Basically, we take the formula we had before, change in displacement divided by change in time, and then we say, what happens to this as the change in time approaches 0? Once we have the formula behind displacement, all we have to do is plug it in. There's usually a tasty cancellation that gets rid of the delta t at the bottom, and we're left with a function. This is known as differentiation. So for every grain of t, there's 2t grains of displacement.
But I bet you already knew that. See, when I was 12 and we were doing quadratic sequences, to find the x squared coefficient, we just took the second difference. It was only later that I realized what we were actually doing was approximately taking the second derivative.
Here's my approximation of sine going to the sixth difference using this method.
And if you're still unsure about why we should care about calculus, here are some things that calculus can help us understand better.